We will continue our discussion on the discrete random variable, and now we will see a problem. So this is a problem where x is a random variable and it may assume 4 values with the probabilities 1 plus 3x by 4. Okay, and 1 plus 3x by 4, 1 minus x by 4, 1 plus 2x by 4, and 1 minus 4x by 4. Find the condition on x so that these values represent the probability function. So we have discussed about the two things in the previous lecture about the probability mass function. It is usually represented like px of xk, okay, and the probability distribution, cumulative distribution function, okay, cumulative distribution function, okay, this we have already discussed. So cumulative distribution function is nothing but the probability that the random variable x takes the value which is less than or equal to the value xk, okay, or less than or equal to x, or you can say x in general. So this we will call with a simple notation fx of x, okay. So this is the cumulative distribution function. So we can see here there are 4 random variables in the question. So as far as the question is concerned, there are 4 random variables. And I can say there are 4 random variables. That means it is countable a finite number of random variables. So it is a discrete distribution. So we have x1 as one random variable, then another is x2, and another you can say x3, and another you can say x4, okay, and all are coming is in general. We can say it is the general notation capital X for the random variable. So your x can take the values, you can say you can take the values x1, but it has a probability p1, and it has been given here your p1 is 1 plus 3x divided by 4, because this has been given. There are 4 random variables. Next, another you can x also can take the value x2, and the x2 is having a probability mass function. So this is the probability mass function. So this is x2 is equal to 1 minus x, okay, by 4. It has been given here, you can see it has been given here. Next you have another random variable, your x3, which is having sorry, this I have noted it in a different way here. X2 is the random variable, what the probability is actually 1 minus x divided by 4, okay. Next you have the random variable x3, which is having the probability mass function. It has been given in the question actually. So it is just the probabilities of those discrete random variable. Probability mass function means the probability of those discrete random variables. So it is nothing but 1 plus 2x over 4, okay. Similarly you have x4, okay, you have x4, and x4 is having the probability p4, which is 1 minus 4x over 4, okay. Now the question is, find the condition on x. Find the condition on x so that these values represent a probability function of x. That means if it is representing all this p1, that means you have p1, you have p2, you have p3, and you have p4. What is the condition that it represent, all these represent the probability mass function. You know that if it is a probability mass function, we have 4 random variables. We have total 4 random variables. If it is a probability mass function, then the total sum, that means sum of all pi, that means I varies from 1 to 4, all pi's, that means you have p1 plus p2 plus p3 plus p4. Sum of all probabilities should be equal to 1. This is the condition. So we will see we have what is the condition. So this is our condition actually. Now what is the question? Find the condition on x. We want what is the condition on x. Okay, we want the condition on x so that everything represent a probability mass function. Okay, now what is that condition? You know that p1 is equal to 1 plus 3x by 4, and p2, I will rewrite it again, is 1 minus x by 4, and p3 is equal to 1 plus 2x by 4, and p4 it is given as 1 minus 4x by 4. Okay, now you know that all the probabilities also should satisfy another condition, that is all the probabilities are greater than or equal to 0 and all the probabilities are less than or equal to 1, right? That means all the probability mass functions will be between 0 and 1. So we should have a condition that this number should be greater than or equal to 0. That means the first condition. So it is greater than or equal to 0 means what? What is that? If it is greater than or equal to 0, then the value of x, then your x should be greater than or equal to minus 1 by 3. If you put x is equal to if x is less than 1 by 3, minus 1 by 3, then this p1 will become negative. That is the problem. Okay, and another condition we will talk about now, about the condition p1 is greater than 0. So now if it is greater than 0, suppose p2 is greater than 0, then we have the condition only if x should be less than or equal to 1, right? If x become greater than 1, 1 minus x become negative, right? That is the main problem. Then it is not a probability mass function. Similarly, this should be greater than 0. Then what is the condition? Then 1 plus 2x should be greater than 0. That means 1 plus 2x is greater than 0. That means your x should be greater than or equal to minus 1 by 2. Okay. Similarly, for p4, for greater than 0, then what is the condition? Then the condition is 1 minus 4x. That means x should be less than or equal to 1 by 4. Now you can see all in all probabilities there is a factor by 4, by 4, by 4, by 4. So whatever be the value of x, since there is a factor of 4, that is 1 by 4 in the first probability, whatever be here on the first probability, let's say it's p1, this is p2, let's say this is p3, everywhere you can see by 4, by 4. So the condition regarding the total probability equal to 1, you don't need to worry. This condition, not this one, you don't need to worry. It is because if you sum all these things, then it will be automatically less than or equal to 1. It will be 1 anyway directly. So what will be the possible value of x? You see here we have some conditions from the above. That means x should be greater than 1 by 3 and x should be less than 1 and x should be greater than minus 1 by 2. Okay, and x should be less than 1 by 4. So you see, if you take these two conditions, x is less than 1 by 4 and 1 by 2. So which one you will choose? You see here 1 by 4 is the smallest number, and if I choose a value which is above 1 by 4, then the condition for p4 will not be satisfied. So my x should take the value less than 1 by 4. This is my condition, first condition. Next, if I compare the other two, that means if I compare these two, you see here x should be greater than minus 1 by 3. which is greater, 1 by 3 or minus 1 by 2. So you can see here x should be greater than minus 1 by 3. So if I choose x as minus 1 by 2, then the condition for P1 will not be satisfied. So I have to take a condition x should be greater than minus 1 by 3. So my value for x, actually it is between minus 1 by 3 and 1 by 4. So this is my answer. Okay, I hope this is clear to you. Next we will see another problem. So before going to the problem, I will explain some more concept regarding the probability mass function and probability cumulative distribution function and the related concepts. So what we are going to discuss, so we have the probability mass function, which is usually denoted as px of xk, and the cumulative distribution function, which is nothing but the probability that x, the random variable x, take the value, this is the random variable, takes the value which is less than or equal to xk. Okay, so this is the cumulative distribution function. Now we will explain very important concept like the mean of the random variable. Mean means, actually it is also known as the average. So how you can find the average of the random variable? You know that we have suppose you have some numbers, for example, as you have some numbers, for example, let's say 3, 4, 5, 6. How to find the average of these numbers? This is nothing but 3 plus 4 plus 5 plus 6 divided by 4. I can write like this average in another way. It's 1 by 4 into 3 plus 1 by 4 into 4 plus 1 by 4 into 5 plus 1 by 4 into 6. The same equation I am writing in another way. So you can see here the contribution of 3, you can see here the contribution of 3, the number 3 is only 1 by 4, the contribution of 4 is only 1 by 4, the contribution of 5 is only 1 by 4, the contribution of 6 is also 1 by 4. That means we are assigning equal contribution for all, and that's what the average you can say. So the average actually in the meaning, the term average is having lot of another physical meanings also. Suppose if you are taking a voltage waveform, average means actually it is nothing but the DC content in the signal. DC content in the signal also, it is having another important significance. For example, you have a signal, let's say it's having a value 1 and 2 and 3 and let's say this is 1. Then what is the average of the, what is the average signal? The average signal means it is here. What is that average? This average you can say it is 1 plus 2 plus 3 plus 1 divided by 4. Okay, let's say if you have one more signal, let's say one more, it's 2, then you have to add 2, then divided by 5. So what is the contribution? That it is nothing but 1 by 5 into 1 plus 1 by 5 multiplied with 2 plus 1 by 5 multiplied with 3 plus 1 by 5 multiplied with 1 plus 1 by 5 multiplied with 2. So like this it is going. So you can see that the contribution of each is 1 by 5. 1 by 5 is common everywhere, right? That means this is the weightage, you can say, weightage for each sample. So this is one sample, this is another sample, this is sample 1, this is sample 2, like this. Okay, this is sample 3 and so on. So you can see this is the contribution. Now in terms of probability theory, why we are defining this main terminology? So suppose you have a noise signal, I am talking about the discrete time signal, not the continuous time signal. You have a, because I am talking about the discrete distribution, the continuous distribution I will discuss later. Then there I will discuss about the continuous time noise signal also. So this is going up to infinity. Okay, now this is your random variable x. It can take any values. Let's say it takes the values x1, x2, x3, x4, okay, x5, all these things. Okay, let us assume that it takes values only from a specific interval, or sorry, from a specific values. For example, your x takes the values only from a set x1, x2, x3 up to x10. Okay, so you can assume this not as a regular noise anyway. You can assume that it is a noise which takes only these particular values. Now there will be some probability for this x1, because x1 will take the random variable x will take the value x1 with a probability. Let's say it's px1. Similarly, this having px2, like this has px3. But I told you this is px, okay, this is px10, but I told you that the sum of all this px, xi, I varies from 1 to 10. This is equal to 0, sorry, this is equal to 1, right? So as I told you that the sum of all this pxi, that means I varies from 1 to 10, here it will be equal to 1. Okay, then you can define the average. Actually, suppose all these probabilities are equal. If all are equal probabilities, then what will be p1? P1 will be, there are 10 samples here. There are 10 there are 10 you can see here there are 10 values for x, or the random variable x. Then each one will be having a probability 1 over 10. That means I can represent pi as 1 over 10. Then summation pi for I varies from 1 to 10 will be equal to summation I equal to 1 to 10, 1 over 10. This is nothing but 10 times 1 over 10, which is 1, right? So if that is the case, you know how to find the average. You see here the same values. Actually, this may be x5, this may be x2, this may be x10, this may be x8, this may be this may be x8, this may be x9, this may be again x10, this may be x1, this may be x3, this may be x2, this may be x5, like this. So it is repeating many times, an infinite number of times. Then for this particular signal, let's say this is an x of n, you can say this is x of n. We will call this as a random process. We will come to this later. So what is the average of this? What is the average you can expect? That means what is the average? As in the previous case, as I told you, you see here the average will come here, right? Then what is the average of the signal that you can expect? That means what is the average value of x, or the average we will call it as x mean, x bar. Okay, this is the average. So x bar, not small x bar, it's not capital, it's small letter, so it's x bar. Okay, or you can have it's mu x. Okay, it's mu x. Mu means actually it is the average, it is the notation. So if all are having equal probabilities, then you can find the average very easily. That means it is you have all the values x1 plus x2 plus x3 plus x4 plus x5 plus x6 and so on up to x10 divided by 10. You see here, since I have assumed all has equal probabilities, and I can have the same thing, that means the number of repetition for x will be same as that of x1, that will be same as that of x2. So I can assume like this. Okay. Now, if all are, this is the situation if all are having equal probabilities. Okay, but there is an issue if PIs are not same. Okay, if PIs are not same, that means your x of n, your signal x of n, it is having x1, maybe here x3, it may repeat x4, maybe x2, like this it is going on. Okay, now you observe the signal for, maybe you observe for 1 lakh samples, you observe for 1 lakh samples. Okay, observe for 1 lakh samples, and out of this 1 lakh samples you observe that you have x1 is repeated maybe some 20,000 times. Out of 1 lakh samples you are observing this random phenomenon, the samples of this random phenomenon, and you have collected 1,000 samples, sorry 1 lakh samples. Then x1 is, you found that there are 20,000 x1, and you found that there are 10,000 x2, you also x3 maybe 5,000. Okay, maybe x4 is also 5,000. Okay, now x5 maybe 10,000. Okay, so you see here 10,000. My x6 may take 5,000 times, then x6 x7 let's say take 5,000 again. Okay, x8 is 10,000, then x9 is 10,000, and my x10 is 20,000. So I got a total of 1,000 sample. Then what is the average? Actually, how to find the average? To find the actual average, you find the average. If you don't know the probability theory also, you can find the average by, you have x1 which is repeated how many times? 20,000 times. Okay, then plus your x2 is repeated how many times? 10,000 times. Okay, we'll write it in another way. You have x1, and x1 is repeated how many times? 20,000 times, plus this is 10,000 times, x2 is repeated 10,000 times, and so on and so on, and finally your x10 is repeated 20,000 times, divided by the total number of samples is 1 lakh. So it's 100,000, that means 1 lakh. Okay, 1 lakh. So this is how. But you see here, if you take this term, for example, if you take this term, what is that? 20,000 by 1 lakh, it's 1 by 5, right? That means I can see here the average is nothing but 1 by 5 times x1 plus, now if you see this one, 10,000 by 1 lakh, it is 1 over 10, it's 1 over 10 into x2, like this it is going on, and finally you are getting, this is 20,000 divided by 1 lakh, that means it is nothing but 20,000 by 1 lakh is 1 by 5, right? So 1 by 5 into x1. So this is how it is calculating. So this is the final average actually. But you see here, I have 20,000 sample. If I take this one, I have 20,000 samples of x1. If I have 20,000 samples of x1 out of a total of 100,000 samples, that means it is the frequency of occurrence of the x1, it is 20,000 out of 100,000. That is the total number of favorable outcome for x1 divided by the total number of outcomes. So you can assume this as total number of outcomes, right? Number of outcomes. and this is the favorable outcomes for x1. So you can assume that this is nothing but the probability of x1 actually, which is we denoted as p1. Okay, in the previous situation, actually in the previous pi, we have denoted it as pi. So it is nothing but p1. Similarly, for x2, you can see here it is about 10,000 samples out of, this is 10,000 samples out of 1 lakh samples. That means 10,000 divided by 100,000, that means 1 lakh. So this is nothing but it's the probability of x2. So you see here in this notation, everything, this is nothing but the probability of x1, and this is the probability of x2, and this is the probability of this is 10, so it's a probability of x10. So the average I can denote like this, it is the summation. Okay, I will take the probability of xi and I will multiply with, you see here this is x1 and this is x2, so I will multiply with xi, and I will do this for I equal to 1 to 10 for our this particular example, So in general, I can find in general, so I can find the mean. Okay, mean is also known as the average. Okay, or I can say the DC content. In signal processing, we will call it as the DC content. So the mean is for the discrete random variable. That means for the discrete random variable, we can denote like this: summation p of xi, okay, into xi. So this is, or I can denote in another way, it is nothing but xi into p of xi. Okay, so this is the mean of the random variable. So you have to remember this formula. It's very, very important formula, mean of the random variable. Okay, now it is also denoted as the mu, it is mu of x, or it is also denoted as x bar. Okay, so the mean of the random variable mu x is nothing but summation xi into p of xi for all I. We have to consider all I, that's it. The previous example, we have I varies from 1 to 10. So this is the situation. Now we will see what do you mean by the variance. Okay, the variance of the random variable. So the mean and the variance now. So we are going to discuss about the variance of the random variable. So usually it is denoted as sigma x square. Okay, so the notation is the sigma x square. Okay, now we will see what is the variance. So it is the square of, it is the square of, it is the average. Okay, it is the average of square of deviation from the mean. Okay, so you know that we have mean as, what is mean? Mean is mu x, it is nothing but summation for all I, okay, p of xi into, okay, I will just first write here xi into p of xi. This is the mean of the random variable. Now what is the deviation? Actually I told you about the deviation first. What do you mean by deviation? Deviation from the mean. That means mean is actually mu x. So deviation from the mean means you have the random variable xi, it is having a difference from the mean of the random variable mu x. This is the deviation. Then I am talking about the square of the deviation. Okay, square of the deviation. That means the square of deviation. What do you mean by square of the deviation? You take this deviation mu x, xi minus mu x, and square it. After that, what you are going to do, you are finding the average of the square of the deviation. That means you are going to find the average of this. Find the average of this. That means you know how to find the average. Mean means actually average. So you know how to find the average. Now for xi, the average of xi is actually mu x. That you can find like this. Now I am going to find this average, and this average is known as the variance. So sigma x square is nothing but, how to find the average? I will have to sum for all I. That means I have to sum for all I varies from 1 to whatever it is there, how many elements are there, according to the number of elements for all I. Now instead of xi, as in the previous case, here you can see in this previous case, for mean, for the definition of the mean, we have considered xi, but here we have to consider xi minus mu xi, because I am finding the average of the deviations, average of the square of the deviation. That's why I am finding the average of the square of the deviation, and this is nothing but the square of the deviation. So average of the square of the deviation, that means I have to take the square of the deviation and I have to multiply with the probability of xi, okay, and I have to sum it for all I. So this is known as the variance. I hope this is very clear to you. Okay, so the variance sigma x square, we will call it variance sigma x square for the discrete random variable. We are talking about the discrete random variable. So it's for all I, we have to take xi minus mu x. I have to square the deviation and I have to average it. How to average? You have to multiply with pxi and sum. So this is the variance of the random variable. So I would like to make a note on this. To find the average of any variable in probability theory, here probability theory, what to do? Let's say the variable is some let's say some variable z. How to find the average of this? The average is nothing but you have to sum for all I. Okay, this I am talking about discrete. Okay, discrete variable. You have to sum for all I and you have to take this z and you have to multiply it with the probability of zi. That's it. So this zi can be anything. That can be a the variable itself, it can be the deviation from the mean, anything. Okay, so this is a general note anyway, so it will be helpful for you. This is the general note. Now from this above theory, I can derive one more thing, that is known as the standard deviation. I think you might have heard about this standard deviation. Okay, so the standard deviation So what do you mean by standard deviation? It is nothing but the square root of, it is nothing but the square root of variance. So that means the standard deviation is usually denoted as sigma x. That means you have to just take the square root of sigma x square. This is nothing but square root of summation for all I xi minus mu x, the whole square into p of xi. That's it. Okay, so just take the square root of the variance. So this is also known as, this is known as the standard deviation. So I hope this is clear to you. So we have studied two things, mean and the variance, and a related concept which is the standard deviation for the random variable. So everything we have discussed only for the discrete random variable. Okay, now we will see a problem. Okay, we will see a problem. So there is a random variable x. So we are talking about discrete random variable. So the random variable x has the following probability distribution function. Okay, it is having the probability distribution, or we can say this is also known as the probability mass function. Okay, so don't confuse. So in some textbook you can see they have used distribution also. Okay, and in general distribution, the probability distribution means actually the random variable along with its probability mass function actually. So distribution, so this is the probability mass function we will say, and this is the random variable. So the random variable x takes these values. So x has following choice, just -2, -1, 0, 1, 2 and 3, only 6 values. So it is a discrete random variable, so it's a finite set anyway, it's very easy to, and its probability mass function has been given. The first part of the question is to obtain the k. You can see the probability mass function contains some terms like k. So we have to find what is this k. But we know that, so we will solve the part A, find k actually, find k. You can see here the probability mass function is having a property that sum of all the probabilities will be equal to 1, right? So here you have 6 random variables. So I varies from 1 to 6. So this is nothing but you have 0.1 as the first one, plus k plus 0.2 plus 2k plus 0.3 plus 3k. This total will be equal to 1. Am I correct? So you can see here this is nothing but 2k plus k. So the value of k you will get it as, if you solve this equation, you will get this value as 1 over 15 if you solve this. Okay, you can solve this equation, the above equation. So you can see it's 0.1 plus k plus 0.2 plus 2k plus 0.3 plus 3k is equal to 1. So you solve this equation and find the value of k. Now if you get the k, if you can find the distribution, okay, then you can find the distribution of random variable. So the distribution is, you have the random variable x, and this is the probability mass function for the x. So what are all the random variables? -2, it can be -1, it can be 0, it can be 1, then 2 and 3. Okay, then it's no issue, this is 0.1, and here this is k is there, so it is 1 by 15. And what about this 0? 0 is just 0.2, and this is 2k, so it is nothing but 2 by 15. Okay, then this is 0.3, okay, and this is 3k, this is 3 by 15. Okay, now if you sum all these things you will get 1. Okay, you can check it. So this is our column, new distribution. This is our actual distribution after finding the k. Okay, this is the k. You can find the k and get the distribution. Okay, now we will use this for the entire problem. Now what is the part B? In the part B you have to evaluate what is the probability that x less than 2 and the probability that x is between -2 and +2. So it's very easy thing. You see the part B, the probability that x less than 2, that means x less than 2 means, you see here x takes the value -2, -1, 0, 1, 2, 3. X less than 2 means what? X can be -2 or -1 or 0 or 1, right? It is the nothing but the probability that x can take the values like x may be -2 or -1 or 0 or 1, right? This is x less than -2. I told you whenever I use the term or, you can add. This is the addition actually. Or means addition. So you can see here it is nothing but the probability that x is equal to -2 plus probability that x is equal to -1 plus probability that x is equal to 0 plus probability that x is equal to 1, right? So you will get it as you can add it. Okay, this you know, this is 1 over 10 anyway. So 1 by 10 plus 1 by 15. Okay, and this is 2 by 10, you can say. So 1 by 15 plus what is it, 2 by 10. Okay, then 2 by 15. Okay, this is plus 2 by 15. So this is the answer. So you will get all these things as 1 by 2. This is the answer for this. Now what is the probability that the random variable x takes the value between that is the second part of the question, between -2 and 2. Okay, you can see here in the question. Okay, so between -2 and 2, that means it is nothing but the probability that x can take the value between -2 and 2 means what? It can be -1, or you can say, or it can be 0, or it can be 1, right? So what is the probability of -1? We will see the probability of -1 is 1 over 15 from the table. It's 1 over 15 plus, I told you whenever you have or, it is nothing but the plus. Or 0 means, what is the probability of 0 is 0.2, that means 2 over 10 plus, again, what is the probability of 1? It is nothing but 2 by 15, right? It's 2 by 15. Okay, so if you add all these things, you will get it's 2 by 5. So that's about the part B. Okay, next we will see the part C. Find the CDF of the x. Okay, that is C. So part C, actually it is nothing but the CDF of the x. So part C, it is the CDF of the random variable x. That means CDF means what? What is the CDF? We will usually denote it as fx of x, right? This is the CDF. But x takes the values, I told you x can take the values like -2, -1, 0, then 1, then 2 and 3. So we have to find for all this, because we have only 6 variables, and we have to find for all this. So fx of -2 is nothing but, I told you about the definition, it is nothing but the probability that x less than or equal to x. So it is nothing but the probability that the random variable x takes the value less than, so this is random variable, we can just use actually basically capital X is the good notation. Anyway, in the question actually they have used small letter, that's why I have used. Anyway, the capital X is the best notation, capital letter is the best notation. Now the probability that x less than or equal to -2. Okay, but you see here what is the probability that x less than or equal to okay, let me see what is the probability that, first before this I can explain you one more thing. What is the probability that x less than -2? There is nothing less than -2, because this the random variable described here, it is actually starting from -2, so there is nothing less than -2. So this is equal to 0. Okay, so before -2 it is 0 actually. So I can start from here now. Probability that fx of -2, that means the cumulative distribution of -2, is nothing but the probability that x less than or equal to -2. There is nothing less than -2. I told you it is less than -2 plus probability that x equal to -2. That means I can write like this also, right? But this is 0, and this is actually, I told you we have something here, it is 1 over 10. So it is 1 over 10, right? So it is 1 over 10. So fx of -2 is nothing but 1 over 10. That's it. Now fx of -1, we will talk about next one. It's -1. fx of -1 is nothing but the probability that x less than or equal to -1. This is nothing but the probability that x has only two values here, x is equal to -2 plus probability that x is equal to minus 1. That means it is nothing but x is equal to minus 2 is 1 over 10 plus x is equal to minus 1, you know it is 1 over 15. So it is 1 over 15, it is 1 over 15. So this is nothing but 1 over 6. Similarly, you can calculate for fx of minus 0, you can get fx of 0 as the probability that x less than or equal to 0, which is nothing but probability that x is equal to minus 2 plus probability that x is equal to minus 1 plus probability that x is equal to 0. So you will get this as 1 by 10 plus 1 by 15 plus 1 over, so what is that, 0 is actually 1 by, it's 2 by 5, it's 2 by 10, right, 2 by 10 I think so, yes, 2 by 10. So you will get it as you will get this answer as 11 by 30. Okay, similarly you can find fx of 1 and you can find fx of 2. I think it's only up to 2, so not only 2, it is 2 and 3. Then fx of 3, you will get this as it's the probability that x less than or equal to 1. So you have to add all the probabilities till 1 and you will get it as 1 by 2. Similarly, this is the probability that x less than or equal to 2, you will get it as 4 by 5. Okay, similarly this one means what, the probability that x less than or equal to 3, that means it is nothing but the probability that x is equal to minus 2 plus probability that x is equal to minus 1 plus and so on till you have x is equal to minus 3, x is equal to 3. That means you are adding all the probabilities. That means you can see here it is equal to 1. So when you draw all these things, you can see this is your minus 2, this is your minus 1, this is your 0, and this is 1, and this is 2, and this is 3. Okay, now I can have the cumulative distribution here. You see here it is till it is, you see this one, so this was till up to minus 1, it is not included, minus 1 is not included, it was 1 by 10, 1 by 10, so this was 1 by 10. Then at minus 1 it's again increased to, I think it is 1 by 6, 1 by 6. Then at 0 it again increased to 11 by 30. Okay, you see here I am using a I am darkening this portion because it is starting from, it is to represent, it is starting from 0 actually. So this part is not included in minus 1, so it is included here actually, and this part is included to minus 2, and it is at 1, you can see here we have 1 by 2, and this become this become 4 by 5, and finally it become 5 by 5, that means it's 1. Okay, you can see here. So this is the distribution function. This is nothing but fx of x. Okay, cumulative distribution function. Okay, please note this thing. Okay, this is the cumulative distribution function, and whatever before minus 2, it was 0 here, it was 0. Okay, there was nothing. Now we have one more part in this problem, so we will discuss that too. You can see here evaluate the mean of the random variable. That's it. You see here, this is the part D, evaluate the mean of the random variable. So what is the mean of the random variable? So the mean of the x, that means we will denote it as mu x. Okay, this is our notation, mean of the random variable as mu x. And what is that mu x? It is nothing but summation for all I, then xi into p of xi. Okay, so what is it? This is nothing but summation for I equal to 1 to 6 xi into p of xi. That means it is nothing but first random variable was minus 2, you multiply with its probability, it was 1 by 10, then plus the second random variable was minus 1, you multiply with the probability, it is nothing but 1 by 15, I think so, yes, it's 1 by 15. Then you take the another one, that means 0 as the random variable, multiply with 1 by 5, so that is the probability. 1 by 5 means 2 by 10, actually I have written like this, 2 by 10, 2 by 10, then plus another random variable is 1, you have to multiply this 1 with 2 by 15, is its probability, plus 2 is the random variable, multiply with 3 by 10, plus 3 is the random variable, multiply with the probability. What is the probability? I have to check. Yeah, probability is 3 by 15, so it's 3 by 15. It's 3 by 15. Okay, if you do like this, finally you will get the answer as 16 by 15. This is how you can find the mean. Now, how you can find the variance anyway? What is the variance? It is not asked in the question. The variance is sigma x square. How to find the variance? Sigma x square. It is summation for all I, then x minus mu x, that means xi minus mu x square into p of xi. So this is nothing but you have xi and you have mu x. You have already got mu x from the previous as 16 by 15. Okay, so we can basically use this idea. So what is xi? First xi was minus 2 minus 16 by 15 into the square, and you have to multiply it with the probability. Probability was 1 over 10. So this is the first, plus minus 1 was the next random variable. You have to subtract 16 by 15 and take the square and multiply with its probability. It was 1 by 15, so that's it. Then plus, then the next random variable was 0 minus 16 by 15. Okay, then you have to take the square, and what is the probability? Probability was 2 by 10. Then you have to, this is the, then what is it? Next you have the random variable 1 minus 16 by 15. You have to take the square and multiply with the probability. The probability was 2 by 15, actually you can refer the table, plus, okay, then it's 2 was the random variable, 2 minus 16 by 15. You have to take the square and multiply with the probability. The probability was what was the probability? I need to check. For 2, what is the probability? For 2, the probability was 0.3. That means 3 by 10 anyway. So this is 3 by 10. Let me check here. Okay, 3 by 10. 3 by 10. Then I have the next the random variable as 3 minus 16 by 15 the whole square, and multiply with the probability was 3 by 15. Okay, so I will get some answer. You can check it out. Okay, I'm not going to solve this. So this will be the variance of the random variable. And how to find the standard deviation? The standard deviation, how to find? If you know the mean, you can find the sigma x square, and if you take the square root of the sigma x square, you will get the standard deviation. So this is how. So you can consider the previous answer and take the square root of this answer. Okay, this is the answer, and you can take the square root of this answer and you will get the standard deviation. So this is how you can solve this problem. So I hope it is clear to you. We have one more problem in this session. It is a good example. This was the question that I have asked in the previous exam, the last year. We have the question: a random variable x takes the small x, that means the random variable x takes the values small x, and the small x are given here, you can see here, and this is the probability mass function for this random variable. Then what is the first part? The first part is to find the value of k. This is the first part. So you know that how to find k. It's sum of all probabilities will be equal to 1, right, for all I. That means 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k is equal to 1. That means you are adding all the probabilities, okay, for all the 8 random variables are there. That means it is starting from 0 and ending at 7. So 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k equal to 1. So if you add all these things, you will get the equation. Actually this will be 10k square plus 9k equal to 1. That means you can write this equation in another way: 10k minus 1 into k plus 1. Okay, you can split this equation like this. This is equal to so you can, okay, I will write the steps: 10k square plus 9k minus 1, this is equal to 0. This is the equation. Okay, so this equation you can rewrite like this. So you will get 10k minus 1 into k plus 1. You can rewrite that this is equal to 0. So what will be the value of k? You will get k equal to 10 or k equal to minus 1. You will get two values for k, but which one you will select? That is the main issue now. So you can see here there are some probabilities which is having the probability as k. So for example, the probability of 1 is k. So if you choose the value of k as minus 1, you know that the probability will never become negative, right? So the value of k which is k equal to minus 1 is not a suitable one. So we will select the value of k as 1 over 10. So when we select k as 1 over 10, because if I choose the negative value of k, you can see that some of the probabilities will become negative, and it is against our axioms of the probability, so we cannot select it. So we will choose k equal to 1 over 10. Now if I choose like this, then I have the random variables x as 0, 1, 2, 3, 4, 5, 6 and 7. Okay, these are all the random variables I have. Now what will be each probability? Okay, we will see. Then what is p of xi? Okay, this is xi and the other one is the p of xi. Okay, what will be these probabilities? We will see. What about the first one? For x is equal to 0, you see here it is 0, so no change, 0. And the second one, you can say it is k, and k is 1 over 10, so it is 1 over 10. Okay, similarly the next one for 2, you can see it is 2k. For 2 it is 2k from the question, so it is 2 over 10. Okay, similarly for 3 you will get 2 over 10. Okay, and for 4 you will get 3 over 10. Then for 5 you will get 1 over 100, you will get 2 over 100. And for 7, okay, for 7 you can see that it's 7 k square plus k, it becomes 17 actually, 17 by 100. Okay, 17 by 100. So these are all the probabilities. Okay, so this is the actual distribution. We can say this is the actual distribution. That means the cumulative distribution function of the random variable x. Okay, now we will see the second part of the question. You can see here what is the probability that x is between 1.5 and 4.5. okay, given that x is greater than 2, right? So this is a question which is related to conditional probability. Okay, you can see here, I will write the question. What is the, this is the first part, I think. Yeah, first part is over. The second part, what is the probability that the x can take the values which is excuse me. So what is the probability that x takes the value between 1.5 and 4.5 given that x is greater than 2? So it is very easy from the question itself. You can see for x greater than 2, for x greater than 2, that means the outcomes are actually 3, 4, 5, 6 and 7, right? Then what is the probability that it is between 1.5, that means it is greater than, so we have only these outcomes, right? Then then the question is x is greater than 2. Given that x is greater than 2, what is the probability that it is greater than, it is between 1.5, that means if, that means given x greater than 2, given x greater than 2, then we have outcomes corresponding to x less than 4.5 and greater than 1.5 as, what are all the outcomes? That means given that x is greater than 2, that means you can count only this. That means you have 3 and only 4, right? You have 3 and 4, because this 3 and 4 is, you see here, it is greater than 2. This 3 and 4 are greater than 2, and both are between 1.5 and 4.5. This is the meaning. This is between 1.5 and 4.5. So this is satisfying two conditions. So we have only two outcomes. So what is the probability according to this? What is the formula for conditional probability? Okay, we will see the formula for conditional probability. You know that the probability of A given B was nothing but the probability of A intersection B divided by the probability of B, right? The probability of B. Am I correct? So what is here B? Here B means it is nothing but the outcome x greater than 2, and A means the outcomes x is between 4.5 and 1.5. okay, so these are all the two things we have to be very careful. So that is what but we know that what is the probability that x greater than 2. So we have to know two things. We have to know what is the probability of A intersection B, and I told you in the previous slide that A intersection B means I have only two outcomes, that is nothing but 3 and 4. okay, that means your A means greater than, A means what? A means, I will use another color. So A means what? A means you have lot of outcomes, that means you have 3 and 4. okay, not lot of, you have only 3 and 4 because it is between 1.5 and 4.5. and B means what? Is greater than 2 as defined. So B is greater than 2 means what? Greater than 2 means you have 3, 4, 5, 6 and 7, right? You have lot of outcomes. Now what is A intersection B? A intersection B means it is nothing but 3 and 4, right? So what is the probability of A intersection B? The probability of A intersection B is nothing but the probability of 3 plus probability of 4, right? So it is nothing but the probability of 3 is, what is the probability of 3? I need to check it. 3 is 2 by 10 and 4 is 3 by 10. That means 2 by 10 plus 3 by 10, it is nothing but 5 by 10. So this is the probability of A intersection B. And what is the probability of B? The probability of B is nothing but, you have to take into account all this. That means it is nothing but the probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus probability of 7. So if you take into account all these things, that means you have to add from 2, that means 2 by 10. You can see here it's 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100 and 17 by 100. You have to add all these things. If you get, then you will get it's 7 by 10. So by using this, we can substitute here back. This is nothing but 5 by 10 divided by 7 by 10, then you will get as 5 by 7. So the probability that x takes the value, the random variable x that takes the value between 1.5 and 4.5, given that x is greater than 2, is nothing but 5 by 7. Okay, so this is the idea. Okay, now you can see here okay, this is the idea. Now what we have to do next is, what is the next part of the problem? Let me check. The smallest value of lambda, you can see this is the next part in the problem. The smallest value of lambda for which x is, probability of x is less than, that is probability of x less than lambda is greater than 1 by 2. That means find the lambda in such a way that, this is the third part of the question, find the lambda such that the probability of x less than or equal to lambda is greater than 1 by 2. What is that? We will see for all the variables. What is the probability that x less than or equal to 0? It's nothing but the probability that x less than 0 plus probability that x is equal to 0. There is nothing less than 0, so this is 0, and probability of x is equal to 0 is also given as 0, so this is actually 0, right? But and 0 is not greater than 1 by 2. According to the question, it should be greater than 1 by 2. So the lambda is not actually our 0. Now we will see what is the probability of x less than 1. It's nothing but the probability that x is equal to 0 plus probability that x is equal to 1. So it is nothing but 0 plus probability that x is equal to 1. What is that probability? X is equal to 1 means actually it is 1 by 10. So it is 1 by 10. And 1 by 10, if you compare with this 1 by 2, it is basically 1 by 2 is greater than 1 by 10. So it is not the correct answer. So lambda is not 1. Now what is the probability that x less than or equal to 2 is probability that x is equal to 0 plus x is equal to 1 plus the probability that x is equal to 2. That is nothing but 0 plus 1 by 10 plus 2 by 10, and it is nothing but 3 by 10. Again, it is not satisfying with this. Okay, all these are not satisfying. Now probability that x less than or equal to 3. Okay, find the lambda such that, find the minimum lambda, actually that's it, minimum value of lambda, that is the question. Okay, smallest value that satisfy. So what is the probability that x is less than or equal to 3? If you continue like this, you will get 5 by 10, which is equal to 1 by 2. But you see here, According to the question, it is given as greater than, it is not greater than or equal to. So again we cannot take this, we cannot take this, we cannot take this also. Now probability that x, the probability that x less than or equal to 4 is nothing but you will get it as 8 by 10. Yes, this is satisfying, this is satisfying, satisfying the condition. Which condition? I will show the condition. This is the condition. Okay, this condition is greater than 1 by 2. So what is the lambda? Our lambda is 4. So our lambda is equal to 4 actually. So that is the minimum value of lambda which is satisfying this condition. I hope it is clear to you. Thank you.